All right, we're going to be talking about problem number 3 on section 3.4 worksheet. So problem number 3 is basically giving us a position equation for this boy named Calvin who's driving his car up a hill. So right away, we've got this position equation, and if you're driving up a hill, we're basically going to talk about up is positive motion, down is going to be the negative motion. Does that make sense? Okay. Do we need to plot the graphs of D and D prime, or are we okay with that? Okay. So for what range of times is the velocity positive?
Jenny has a question.
Oh, I'm sorry, Matt, go ahead.
Would we be able to use a calculator for this?
For something like this, I would. Yeah, you know what? And the quiz on Monday, we'll do quiz. We'll do calculator. That's
Yay.
fine. Okay, just for number crunching. The last thing I want right now is to have you get all the calculus right and move it. We'll get you practicing your algebra and arithmetic later. Huh?
Like, could we just solve it by...
Yeah, so that's what I was going to recommend is for what range of times, for part B, what range of times is the velocity positive? Just go ahead and get a velocity equation. And the 99 is gone, and we've got 30 minus 2t. So in order to know where this thing is positive or negative, it's helpful to find out where it's 0 first. So I'm going to set it equal to 0, and hopefully, if my brain's working okay, we're getting a t value of 15 seconds.
Yeah.
We didn't get a unit for this, did we? Okay, so we'll just say t equals 15. Now here's the idea. If that's the only location where the velocity is 0, that means to the left of t equals 15, it's either positive or negative. To the right of t equals 15, it's either positive or negative. So how do I know? Like, what do I have to do?
Test it.
Test it. Like, give me a value you want to test. Okay? So we'll say from 0 to 15, all you have to do is pick a value within that range. So if you test 14, are you getting a positive or a negative out for the velocity?
Positive, right?
We're getting a positive value out. So you can say v of t is greater than 0. And all we did was just test a value. We know at t equals 15, the velocity is 0. And then from 15 onward, pick a value. And what do we get for the velocity? V of t is less than 0.
So in like the solutions, it says like 15 to 33. How would we have known that we got to 33 as like the final value?
Remember, I said we were going to worry about the
Oh,
endpoints.
sorry.
No,
I
that's
didn't know
okay.
That was included in
Yeah, that's talking about an endpoint because otherwise you're assuming Calvin's driving into the ground.
Okay.
We're assuming that his position would have to stop at 0.
Okay, so don't worry about that half yet. Okay.
Yeah, I would expect that if you guys are talking about a rock being thrown up in the air and coming back down, that you could do those because you know it's when the ground is 0, etc. But as far as the problems where it's thinking beyond like driving up a hill and you're going to drive into the ground, we'll keep it pretty basic for this quiz.
Oh my.
Megan?
Hey, Tyra, what was the question for B? Like, what was it asking?
This was saying for what range of times is the velocity positive. So for part B, your final answer would just be this guy. Yep.
Can you explain the last part you did?
This part where I came
Yeah.
up with the t values? Sure. So the first thing was find the derivative,
Well, I got that.
set it equal to
I
0,
didn't like the...
and then this last little part.
Yeah.
So once you know that at t equals 15, the velocity is 0, that's the only value where the velocity was 0. Everywhere else, it must either be positive or negative. So we're saying starting at 0 and going up until 15, pick any value between 0 and 15 and plug it back into the velocity equation. And no matter what you pick, you could pick 2, 5, all the way up to 15, and you'll get a positive value in the velocity.
Okay.
And
Is
likewise,
that just a way to check?
you just test the region. Otherwise, you could have done this graphically and looked at it and said anything above the axis when you graph velocity would be a positive velocity, anything below would be negative. Other questions on 3B before I move on? Okay. For part C, it's asking you, at what time did the car stop rolling up and start rolling back? Okay,
Isn't
I
that
need.
the same thing as setting velocity to 0?
Why?
Because you have to have a velocity of 0 to like change directions.
Right.
So how is that different than like the question that they asked us before?
Well, specifically in part B, they said at what times is the velocity positive.
Oh, okay.
So your final answer for B is the thing that I circled or boxed out. For part C, at what time did the car stop rolling up and start rolling back? And that's just pretty simple. We found that in part B. That's t equals 15. Okay? How far was it from the bottom of the hill at this time? What am I looking for in this one? Tommy? Tommy?
The maximum of the graph, like the top part.
Okay, so how do I find that? If I know that the time is
Plug
15.
into the regular.
Beautiful. Plug in 15 into your position equation. So that
Why 15?
that was the time that we got the velocity is 0. So if he's rolling up the hill and then he has to roll back the hill, that means at the top he had to stop.
Wait,
Dr. Seuss.
Go ahead.
it's asking at what time he's back down.
Right, we said it t equals 15.
He's at the top of the hill.
At what time did the car stop rolling and start rolling back? You're driving up a hill
Yeah.
and then you stop and you're rolling backwards down the
I found
hill.
it when it got back down to the bottom.
Oh, I see. Okay.
That's how I interpreted it.
No, it's all good. What was I in the process? Oh,
You were doing how far from the bottom of the hill?
so 15C. These questions were from another book, so
Okay.
I'll make sure when I ask the questions on the quiz, I phrase it a little more clearly.
That was the hard part about this question.
Yeah.
So it was really
It was just a little weirdly worded. Yep.
So when it's where you'll plug it back into the displacement.
Right, into the
Here,
position
here,
graph. Mm-hmm.
positions. Okay.
Right. Okay. We're good? Anything else? When will he be back down at the bottom of the hill? Part D. If you're back down at the bottom of the hill, what do you know?
Zero.
Oh, that's
What
what I was
is?
talking about.
Position.
Your position away from the bottom of the hill would be 0. So all you have to do is set 0 equal to that position.
This is what I was talking about.
Oh,
in
okay.
The wrong column.
No worries. Okay.
Or it's like 0.67 and 7.
Okay. So again, you solve this using your calculator and you come up with the time. Yep. Anything else? I kind of dig this. This is pretty cool.
It's like multi-dimensional. It's freaking out.
Eli, did you have anything to add?
And the next one? Oh, meow.
Okay. Eli's meowing for us. There you go. It's not what Ringo and Hala sound like, but it'll do.
Is that the name of your cats?
Mm-hmm.
Oh.
Well,
Okay.
the next one, that doesn't make